Today we are going to talk about the Pythagorean Theorem and the Pythagorean Inequalities Theorem. And we'll start off with the Pythagorean Theorem. States that for every right triangle a squared plus b squared will equal c squared when A and B are legs and C is the hypotenuse of the triangle. So in a right triangle, you've got one 90-degree angle. And the two sides of the triangle that make up the 90-degree angle, those are called legs. All right? There's one leg and there's the other leg. The side that's across from the 90-degree angle, that's called the hypotenuse. It's across from the 90. And it's the longest side. Alright, so that is your hypotenuse. So if you were to label the three sides of the triangle, the legs are always labeled A and B. The hypotenuse is always side C. And before we go any further, let's get this in your notes too. That if a squared plus b squared is greater than c squared, the triangle is acute. And if a squared plus b squared is less than c squared, yes, triangle is obtuse. So you'll be using the Pythagorean theorem and this inequalities theorem today to find the third side of a right triangle. And then you can also use these two inequality theorems here to determine if the triangle is a right triangle, and if it's not, whether it's an acute triangle or an obtuse triangle without looking at a picture of the triangle. Okay? I think so. And one more definition that you need to have is on the bottom of page 361. Pythagorean Triple. you'd say that a Pythagorean triple is a set of three non-zero whole numbers Pythagorean triple is a set of three non-zero whole numbers called a, b, and c, where a squared plus b squared equals c squared. An example of a Pythagorean theorem, Pythagorean triple would be 3, 4, and 5. Okay? So we'll say an example would be 3, 4, and 5 because 3 squared plus 4 squared equals 5 squared. All right, 9 plus 16 equals 25.
Does it always look like that? Like it's 2, 3, 4? Oh.
No, and it seems like, I don't know, to me it seems like it would be easy to list Pythagorean triples, but it's not. It wasn't for me anyway. Another one, 3, 4, 5 is one. What is it? 6, 8, 10. 6, 8, 10 is a Pythagorean triple because, you know, for the same reason. 6 squared plus 8 squared equals 10 squared. Right? That's 36 plus 64 equals 100. And there's some more examples of Pythagorean triples on the bottom of page 361. All right, so let's use the Pythagorean theorem here and solve a couple problems. So on the top of page 361, you're given a triangle and you're asked to find the value of x. They give you the picture and they tell you that it's a right triangle. So when they tell you it's a right triangle, you use the Pythagorean theorem. So here's your right angle. You got a side that's 6, a side that's 4, and the hypotenuse is unknown. So you label the sides a, b, and c. The Pythagorean theorem says that a squared plus b squared is equal to c squared. So then you replace the letters with their values. So 6 squared plus 4 squared equals x squared. So 36 plus 16 equals x squared. 36 plus 16 is 52 equals x squared. And then in this case, you would find the square root of 52. And what do you get in your calculator? 7 point something?
7.21.
7.21. So 7.21 equals x. That's the length of the third side. Now, are those side lengths a Pythagorean triple? No, because they're not all whole numbers, are they? This is a decimal, 7.21. What you're going to see in this section is the directions, in this case, say, give your answer in simplest radical form. In Algebra 1, you simplified radicals. All right, so this square root of 52, simplified, or in simplest radical form. The square root of 52, when you simplify radicals, does anybody remember doing that? You found the largest perfect square that went into 52 evenly? Okay? And in this case, when you simplify 52, it becomes the square root of 4 times the square root of 13. Because 4 times 13 is 52. And 4 is a perfect square, so you can simplify the square root of 4. So the square root of 52 in simplest radical form is 2 times the square root of 13. So you can either, you can do this two ways this week. Simplifying radicals is like a whole lesson. It's like a whole week. All right? And they're just expecting you to remember it in the middle of a geometry class, but you're not going to remember it. So look, you don't have to leave it in simplest radical form. You can just find the square root of 52, round it 2 decimal places. Okay? But when you take your quiz on Thursday, this right here.
Wait, you don't have school Friday?
I'm not coming to school Friday, so your quiz is going to be on Thursday.
Yeah.
So look, on a multiple choice quiz, you may see your answer choices in radical form. Okay? All this 2 times the square root of 13 means is to type in your calculator right now 2 times 13 and push the square root button, which is I think 2 above the 9.
3.6055.
And push equals. You have to multiply 2 times the square root of 13.
Oh, so 7.2.
You're back to 7.21, right?
Mm-hmm.
What I'm saying is you don't have to simplify radicals this week. You can just find the square root of 52 in the calculator. But what you have to understand is that the square root of 52 is equal to 7.21. The square root of 52 is also equal to 2 times the square root of 13. And that these two values are equal to each other. Does everybody understand that? Yes.
So back to what you were saying earlier. So the hypotenuse and C are two different things.
No.
The same thing.
Side C is the hypotenuse. Side C represents the hypotenuse in the Pythagorean theorem.
So the hypotenuse is not the little box in the corner.
The hypotenuse is the side of the triangle that's across from the box in the corner. The box in the corner is a symbol for 90 degrees. And be careful when you're setting up these problems. And now X is one of the legs. Your steps are the same. The first thing you're going to do is label the sides. Alright, A and B are on either side of the 90-degree angle. C is always the hypotenuse. So in this case, x squared plus 17 squared equals 20 squared. If you square everything, 17 squared is... Somebody want to square that for me, please?
289.
Alright, so x squared plus 289 equals 400. Alright, in this case, you got to subtract 289 from each side. And x squared will equal 111. And then you're going to find the square root of 111. So x would equal 10.53. So there's your third side of the triangle. Everybody okay with that portion of the assignment? You're just finding the third side of a right triangle. Use the Pythagorean theorem. The second part of the assignment, you are going to be asked to tell if the measures can be a triangle, Tell if the measures can be a triangle. If so, classify. And what they're saying is classify it as a right triangle, an acute triangle, or obtuse triangle. So if they give you three values, and let's say they give you a 7, 12, and 16. Remember your test for a triangle? You take the two smallest and add them together, and they need to be greater than the third side, right?
Yeah.
Okay, so 7 plus 12 is 19. It's bigger than 16. This will make a triangle. So, first part of the question is, tell if the measures can be a triangle. Yes, they can be a triangle. The second part is to classify it. So when you classify it, you're going to take 7 squared plus 12 squared, and you are going to compare it to 16 squared. So 7 squared is 49, plus 12 squared is 144, and you're going to compare that to 16 squared, which is, what's 16 squared? 256. So the 49 plus 144, that's less than the 256, isn't it?
Mm-hmm.
So what did we say? If a squared plus b squared is
It's
less
obtuse.
than
It's a
c squared, then it is an obtuse triangle. Understand?
Yep.
Anybody have any questions?